Here we go. Last but not least, number 14. Given the geometric sequence here, find an expression for the nth term. Okay, well, a sub n equals your first term, 250, times your common ratio to the n minus 1. So all we need to do is find that common ratio, folks, and we are done. How do you find common ratio? Well, you take the second term, 50, divided by the first term, 250. So 50 goes into 250 1/5 times. So that's a 1/5. So there's your equation for any nth term. It says now find the 10th term. So a sub 10 would equal 250 times 1/5 to the 10 minus 1, which actually 10 minus 1 is 9. So now using your calculator, okay, get out your calc and you're going to type in 250 parentheses 1 divided by 5 and the parentheses to the power of 9. I get 1.28 times 10 to the negative 4. 1.28 times 10 to the negative 4, which really would be 0.0000128. So, there you go. 15, solve the system of equations. If the system has one unique solution, write the solution set. If the system has infinite solutions, write infinite. Okay. If the system equation has no solutions, then state that. Okay, there we go. You got a couple different ways you can solve this thing. If you're going to use elimination, I would tell you to probably eliminate the x because there's a negative x there and a positive x there. So I'd go to eliminate the x. I'd take these bottom two equations, and I get negative x plus z, 7z, equals 5. And I would take that with x plus y minus 10z equals negative 4. And I would add those together to get rid of the x. So that gives us y minus 3z equals 1. So now I'm going to eliminate x from the top, and I'd probably use the bottom. So I take these two equations now, bring them here. But by so doing, I'd multiply the bottom one by 3 first. So giving me 3x plus 3y minus 30z equals negative 12. Then up top, I have negative 3x minus 5y plus 36z equals 10. Adding these guys, I combine there, I get negative 2y plus 6z equals a negative 2. At this point in time, I can now bring these guys together and eliminate the y's by multiplying this guy here by 2. So that gives us 2y minus 6z equals 2. On here, I get negative 2y plus 6z equals negative 2. When I add these together, look what happens. I get 0 equals 0. This thing has infinite solutions, okay? So now, go ahead and let z equal t. We're going to say z equals t. If that's the case, then I back substitute into one of these equations. I'd probably do this equation right here. I'd get y minus 3t equals 1 and solve. Add the 3t. So I get y equals 3t plus 1. So I get y equals 3t plus 1. Now back substitute into one of these top equations. I'd probably pick this one right here, because I don't even have to deal with the y. I just have to deal with x and z. I get negative x plus 7 times t equals 5. Subtract 7t over. Negative x equals negative 7t plus 5. Divide everything by negative 1. I get x equals 7t minus 5. So there it is right there. There's your solution set. I would write it as 7t minus 5, comma, 3t plus 1, comma, and t. Infinite solutions. There it is. Done. Hey, good luck on the final, guys. See ya. Bye.